Hey everybody, this is a little bit of help with proofwriting. I'm going to take you through a typical example. I like these ones that make you draw the picture and make you think about an actual figure that exists in real life that might have a property that's worth knowing about. In this case, prove that a quadrilateral, that's a four-sided figure and only a four-sided figure, if it has two pairs of congruent opposite sides, then the figure must be a parallelogram. So quadrilateral, two pairs of opposite sides. Don't draw a perfect rectangle, draw something that's a little bit hinged over so that you're not accidentally drawing something that is idealized. So here are opposite sides that are parallel if they went forever. Don't touch. These guys are also parallel, and these guys are also congruent. So this is the figure we're dealing with. Is it true that this is a parallelogram? Gosh, I don't know. Let's try to prove it. So in order to prove something is a certain figure, you need to know what the definition of that figure. And the definition of a parallelogram is that these opposite sides are parallel, hence the name parallelogram. So we need to show somehow that these sides are parallel. So to help talk about it, let's put some letters down. I'm going to be very boring and traditional. A, B, C, D. Make sure that as you name it, you go in one order or the other. It doesn't really matter where you start. Just want to go clockwise or counterclockwise. So we'll say given that AB is congruent to DC, and I will combine this as sort of both steps in one. Actually, you know what? I'll separate it so that it's really, really clear. So step number one, AB is congruent to DC, and then AD is congruent to BC. And put the little lines over that's showing their sides, their segments, that's also given. And then that's all we are given, that it's four-sided and that those sides are parallel. So what I'm going to think through is what the logic is that will get me to the end and work my way up from the bottom. It's a really helpful strategy to know some basic tactics. Look for vertical angles, look for overlapping angles, look for reflexive sides and things like that. This one doesn't have a lot to start with, but look for anything that's sort of helpful to get you going, and then think, what do I need to make my last step? I know my last step is that A, B, C, D is, I'm going to call it a p-gram for short. And the only way I can say something is what it is because it fits the definition of what a p-gram is, what a parallelogram is, all right? Well, like I said, the definition that those opposite sides are parallel. So the step before it is going to be something like AB is parallel to DC. And then the step before that might be that AD is parallel to BC. So I'm going to think that I need to show these opposite sides parallel. The only way to show opposite sides are parallel, or show any lines are parallel, is through using a transversal. If I want to show these lines are parallel, I need a transversal to show that either AIA angles are congruent or these corresponding angles are congruent. If I can show that's true or that these are, then I can say they're parallel. That's the converse of AIA. So I'm going to draw a little helping line like this. That's called an auxiliary line because, bingo, I've got triangles, and that's going to be a congruent pair of triangles, and I can then say through CP/CTC that the alternate interior angles of that transversal. So I think that's my breakthrough, is to draw that helpful line. So step number 3 is going to be draw AC. And that's just, there's a postulate that's between any 2 points you can draw a line. So I'm just going to call that line between 2 points postulate. Now this is the type of thing, you're just drawing an auxiliary line. That's called an helping line, an auxiliary line. And I'll call it maybe auxiliary line postulate is also acceptable. So if you are stuck for a reason, just explain what you're doing. If it's something that makes sense to you, it'll make sense to us. I'm drawing a line there. So step 4 then is that I am going to try to say, well, these two triangles are congruent. I've already got two sides. That's, a side, that's a side. So I just need to say, oh, this is congruent to itself. So AC is congruent to CA. You don't need to reverse the letters. Sometimes it's helpful. It makes you think about which direction you're going around a triangle. That's just the reflexive property. And then I'm going to say step 5 then is once I've got this side congruent to itself, I've got 3 sides of one triangle congruent to 3 sides of another. Triangle ABC. Here's where I want to be careful to get the letters in the right order. So A is the vertex of this upper triangle made between the 2 and the 3. So I'm going to start with C and then go C, D, A. C, triangle, triangle, C, D, A, and that's S, 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 okay? Well, once I've shown that these triangles are identical, it must be true that if I pick them up and put them on top of each other, that these corresponding angles right here would be equal. So I'm going to just save myself a little bit of time. I'm going to call that angle 1 and angle 2 rather than using the 3 letters. So I'll say step 6 is angle 1 is congruent to angle 2, and that's CPCTC. That's the step that once I've proven triangles are congruent, their parts are. And then if I've got these angles congruent, then that's the alternate interior angles for AB and DC. So that's this side down here. So actually I'm going to cheat a little. I'm going to make this be angle I'll make this be angle 3 here and angle 4 there. And I'm going to turn that into angle 4 and angle 3. It's still CPCTC. Those are corresponding parts, but that'll allow me to say in step 7 that AD is parallel to BC, and that is the converse of AIA. Shown the alternate angles are, so that means the lines are parallel. So now that means step number 8 is going to be that angle 1 and angle 2 are congruent, and that's CP, CTC, and then step 9 is the lines, whoops, I've gone off the page. I'm just keeping going with, I've said now that angle 1 and angle 2 are congruent because of CP, CTC, and then these are parallel again because of the converse. You're going in the reverse order, the converse of AIA. And then finally step 10 is that I've got both sides parallel, therefore I've got my proof that that is a parallelogram. Okay, hopefully that's one example that is useful. Obviously there's a lot more creation going on there, not a lot of blanks for you to fill in. You have to start from scratch, but it shows you how this whole thing works. Good luck.